Okay, let's take a look at combining distributions. A little of this is review, so I'll go over the review part of it, and then we'll add kind of the new part of it. So here's what we got. We got two distributions. We have distribution X, which has a mean of 80 and a standard deviation of 12, and we have distribution Y, which has a mean of 12 and a standard deviation of 3. Okay, so let's talk about the first thing. The first thing that could happen is we could add or subtract a constant. So what I'm saying is I'm going to take distribution X and I'm going to subtract 20. Okay, what that means is I'm going to go into distribution X and take 20 away from every single data value. Now we did this before, and the rules were when it comes to means, the new mean, so the mean of X minus 20, we just do whatever it says. So in this case, we're going to take the 80, we're going to subtract 20, so our new mean is going to be 60. Now the rule with standard deviation is different. The standard deviation of that new distribution X minus 20 is just going to be our original standard deviation. It's going to stay as 12. And the reason it's going to stay as 12 is if I take 20 away from everybody, the distance between everybody remains constant. So like as a basic, just as an example, let's say that somebody in this distribution had a value of 90 and someone had a value of 85. So 90 and 85, they're 5 apart. I'm going to take 20 away from each of them. So now you're 70. Now you're 65. Since I took 20 away from each of them, they're still 5 apart. So that's why standard deviation doesn't change. So with means, we add, subtract. Whatever it says, we add and subtract to means, good. We don't do it to standard deviation. We leave it alone. Okay. Now the next one is what happens when we multiply or divide. So in this case, what I'm going to do is I'm going to do 1/2 of y, or 0.5 times y. So either way you want to think about it. It could be y divided by 2. It could be 0.5y. Either one is fine. So if I want to figure out the new mean, the mean of 0.5 times y, I'm going to do exactly what it says. I'm going to take 0.5. I'm going to multiply it times that original y, 12, and that's going to give me a 6. So means whatever it says to do, do. When it comes to standard deviations, when I multiply or divide, I actually am going to do it. So in this case, I'm actually going to take that 0.5, multiply it times 3. So my new standard deviation is going to be 1.5. So the rule again is this. When I'm dealing with adding or subtracting, only mean. When I'm talking about multiplying or I'm talking about dividing, I do both. So again, the rule is mean, just do whatever the mean says. Standard deviation, I got to remember some rules. I can multiply and divide. I can't add and subtract. So that's a little bit of a review of what we did before. So now what I'm going to do is I'm going to add a new one to you, because this one isn't adding a constant or subtracting a constant. This one is combining two distributions. So what I'm going to do here is the following. I'm going to take the two distributions X and Y, and I want to go ahead and I want to combine them. So what I want to do is I want to find the new mean of X plus Y. We'll hold that same rule in place. Whatever I tell you to do with means, you just do to means. So in this case, the mean of X plus Y is the mean of X plus the mean of Y. I'm just going to take 80 and add 12, and it's 92. As with the constant thing, there's a special rule for standard deviation. And here's what the rule is for standard deviation. First thing, if you remember back when we were doing the expected value, I told you to get standard deviation, we had to go through variance. So kind of like what we talked about was right here. To get standard deviation, we had to go through variance. Well, what I'm telling you is in order to combine the distributions, I got to do the same thing. What I need to do is I need to turn each standard deviation into a variance. So I turned each one of my individual standard deviations into a variance, and then I'm going to add them together. That's going to give me a combined variance. To turn it back into a standard deviation, I take the square root. So what I'm going to have is I'm going to have the square root of 12 squared plus 3 squared. So I'm going to go ahead. I'm going to do 12 squared plus 3 squared. And it's going to give me 12.37. So it's going to give me a standard deviation of 12.37. So the thing I want you to notice, one big thing to notice here, I'm going to hopefully get it all on the screen at the same time. When I take two distributions, I do whatever it says with the mean. So 80 plus 12 is 92. But what I'm going to do is I am going to turn this to variance, turn this to variance, and combine it. And thing I want you to point out is, let me get 2 pens so we can see that. My biggest original standard deviation was 12. When I combine them, I end up with a bigger standard deviation. So it's a rule to remember. When you combine two distributions, the new standard deviation will be larger. So if again, the way, hopefully it logically makes sense, that if I have two distributions that have variability, when I combine them together, I have more variability. So that's our distribution. That's how we do x plus y. Now what I want to do is I want to show you what happens if we subtract them, because really the only things we're going to do is add and subtract. Occasionally we might multiply by a constant, but we'll come to that later. So now I want to find out the new mean of x minus y. So again, I'm just going to take mean x minus mean y. I'm going to do 80 minus 12. I'm going to get 58. All right, no, 68. Okay, 68. I'm going to get 68. So I do 80 minus 12. I end up with 68. Here's the other trick that we're going to know to get that standard deviation of the difference. Again, I still need to turn both into variances, and I'm going to need to take the square root to get it back to a standard deviation. But here's the deal: I am not going to subtract. I'm always going to add. So standard deviation has a rule that when I combine them, I always add. So what it's telling me is that this guy's standard deviation would be the same as when I add them. Whether I add them or whether I subtract them, I end up with the same standard deviation. So that's the kind of the trick to it to make sure you understand, is that when I do means, whatever I say in means is what you do in means. Whatever the question says on means, that's what you do in means. When it comes to standard deviations, there's another rule, kind of like when we did with the constants. We had to remember a rule about, hey, we don't add and subtract, but we do multiply and divide. What I need you to realize is when we combine two distributions, we always use the same formula. And in class, I showed you where that was on your formula sheet. So realistically, I could do anything now. So here's the deal. Let's say that I ended up with the following. Let's say I ended up with a distribution that had the following: 7 times x minus 2 times y. And I want to find the new mean and standard deviation. So what is the mean of 7x minus 2y? What is literally the mean of 7x minus the mean of 2y? And again, we do whatever it tells us in the mean. So it's going to be 7 times the original mean minus 2 times the original mean. So it's going to be 7 times 80 minus 2 times 12. So 560 minus 24 is going to give me 536. So my new mean is 536. For standard deviation, here's the deal. It's going to be a little bit kind of wonkier to look at, but I'm going to kind of walk our way through. First thing I'm going to do is I need to go ahead and I need to take this and turn it into a variance. I need to turn this and turn it into a variance. So 2y squared. Always add them, square root it. So now here's the deal. Inside here is a multiplication. If you remember our rule up here, we do multiplication. So what this is going to be is it's going to be 7 times my original squared plus 2 times my original, which was 3 squared. And I'm going to go to my calculator and I'm going to figure out that that is 84.21. And so this guy's new standard deviation is going to be 84.21. So again, if you kind of think about it, it's bigger than the biggest standard deviation because 7 times 12, which was our original one, is 84. This is still bigger than 84. So that's how we combine distributions, and it doesn't matter whether we're talking discrete, normal, anything like that. This is how we do it. So hopefully that gives a good example of how to do it, and we'll practice that in class. And please ask questions if you got them.